Okay, first thing I want to talk about is what if the sides aren't normal numbers? We had a test where we had problems like this. We'd never done it in the context of inverse sine or inverse tangent before, but we've done them before where you had just a variable. So let's do this one together. Everybody write this one down. Okay, where do you start on a difficult math problem like this? On the inside. All right. There's a couple of phones out and there's a couple of headphones on. Headphones off, phones away. Need your full attention. All right, so we start on the inside. So, I'm not going to say who, but there was somebody who's working on homework now instead of this. Don't do that. Stay focused. This is not easy, and if you skip this part, you're going to be lost in a minute when we take the quiz. Okay, so, EL. What quadrants can't I be in? I'm ignoring this for now. I'm just starting on the inside. Oh, that's the dead zone. You're correct. And why not? Yeah, inverse tangent's only allowed over here. All right, good. You should know that. Next thing. Of the two remaining spots, it's kind of hard to do this unless you write it like this. Tangent of some angle is x over 2. Notice I'm trying to find an angle. If you haven't figured this out yet, that's what inverse trig does, is it finds the angle. You first encountered it, I'm going to just go off to the side for a second, when you had triangles where you knew this was like 3 and this was like 5, and yeah, you could figure out the third side, but that was kind of irrelevant. You wanted to find the angle between them, and you'd go like, oh yeah, that one is sine, cosine, or tangent. Tangent would be opposite over adjacent. We do not have opposite over adjacent. Try again. Sine, cosine, or tangent? Cosine, because we have adjacent and hypotenuse. Okay, so this would be cosine. And you'd use inverse cosine to do this problem? You remember doing that? We had other problems where we used the law of sines, which was a over sine A, little b over sine B equals little c over sine big C. And do you remember that at the end, you a lot of times had something like this? Sine of some angle was equal to 1/2, and then you had to use inverse sine to solve it. Okay, so we've done inverse sine a few times. Back to, we haven't done it with weird sides very often. So when you have an x and a 2, I can't tell if this is positive or not. So I can't tell whether to put it here or here. And what we always did is default to which quadrant? The upper one, yes, quadrant 1. Everybody draw that in there and label the two sides we know and figure out the third side. I know for some of you this is like, come on, Mr. Server, this is really easy. But you should be amazed. You would be amazed at how many kids struggled with this last hour. Could not even remember doing it. It must have been just too long ago in this class when we did this. So tangent is opposite over adjacent. Did you get those are x and 2? And then the third side then must be square root of, do you remember doing these where we do 1 squared and then the other 1 squared? So it's x squared and 4. And should I add them? Only if I've got the longest side. Should I add them? Yeah, so it's x squared plus 4. Is this coming back at all? Okay, you did do it. I know you did. I can show you the test that you had this on. All right, back to the sine thing that I covered up and was like ignoring until now. Now, remember, I've got my angle here. I don't even know what the angle is. The angle totally depends on how big x is. But if all I want is the sine of the angle, would you please write down what you think the answer is? The sine of the angle is just the opposite over the hypotenuse. SVR. Would you tell me what to do?
X divided by square root.
right. Sine is opposite of hypotenuse. X over square root of x squared plus 4. That's it. Very good. All right. Now, bear with me for a second. I'm going to tweak the problem just a little bit. You have a question first?
Yeah.
Would the hypotenuse boil down to x plus 2? Good question. What you're really asking is, can I do that square root? And I can't do that square root. It's a very common mistake to think that you can. A lot of kids would think, oh, I'll just simplify it. It's x plus 2. Nope, it doesn't work that way. It's complicated. This could be like a 20-minute discussion, and we don't have that much time. So don't do that. Just leave it as square root of x squared plus 4. All right, now I'm going to back up a notch. Let's say the problem hadn't been to find sine of this angle. What if the problem had been to find sine of 2 that angle? Do you get where I'm going with this? This is like theta, sine of 2 theta. Do you remember that one? Does actually anybody have that one memorized? Sine of 2 theta. Raise your hand if you think you could pull that one off right now. Awesome. J-on. 2 sine cosine. Very good. Okay, so now let's say this is the problem. It's sine of 2 that. Then I have to use the sheet. I know that one. John just said it a second ago. Can you please try to answer this question now? This is like a theta. So this is like sine of 2 theta. And that's like, okay, and I know some of you, okay, there we go. Yeah, I'm going to hand out the sheets. Hold on a second. Okay, I'm going to help. 2 sine theta cosine theta. So 2 times something times something. Don't overthink this. You just got to find sine of the angle and cosine of the angle. Drop them in. I'll pause for a second while you clean this up, finish it up. So sine is opposite over hypotenuse. X over square root of x squared plus 4. Cosine's adjacent over hypotenuse. 2 over square root of x squared plus 4. And there's your answer. Yes. Sine 2, that's an angle. How do I know that the box thing is an angle? Because it's an inverse trig, and that's what you do to find angles. So let's do one more that's kind of like that. Would you please do cosine of 2, and then there's an angle, and I'm going to do the angle with a different color just to make it really stand out. Inverse tan of 1 over x. Now, cosine of 2 whatever, let's just all agree, since there's 3 options on the sheet that you could pick for cosine. Everybody look at the cosine options. Grab the sheet, lower right-hand corner if I remember correctly. Isn't there one that has like sine squared and cosine squared? So we're going to use the one that says cosine of 2 theta is, did you read that one, Jayan? Yep. And I'm going to, since I have x is my, this has confused a lot of people, I think, during first hour. That's not the angle, so I'm going to stick with theta. X is a side. Okay, we'll get that later. But this is just a recitation of the sheet. Cosine squared theta minus sine squared theta. Do you get, all I need to do is find cosine, and then I'm going to square it. And then I'm going to find sine, and then I'm going to square it. How am I going to find sine and cosine? Because this is going to make one of those triangles like we just did a minute ago. All right, I'm going to pause for a second while you give this a try. All right, so here's what you should have done. You find cosine of this, and then you square it. And then you find the sine of this, and then you square it. So it's not that hard if you have the triangle. Because Doesn't circle trig pretty much always come down to the triangle? And we put it right here because of where inverse tangent is allowed, and because we don't know if it's positive or negative because there's a variable in it, we always default to the first quadrant. So tangent is TOA, opposite over adjacent, and this side will be square root of x squared plus 1. So then, what is the cosine of it? The cosine of it is x over square root of x squared plus 1 squared minus the sine of it, which is 1 over square root of x squared plus 1 squared. And I've decided on this test that I'm not going to require simplification of that. So you'd be able to just leave your answer like that. All right. Any questions? All right. Now, let's see if that really stuck. Let's see if you really got that one. So there's a quiz that I'm about to hand you. That the first 4 questions are really easy. Number 5 is kind of like what we just did. Number 6 is like a stretcher question. It can be done. Think of it like an R4 level question. And then there's number 7 and 8, which again, you should be able to do. So 6 is the evil one. Watch out for number 6. Don't stress about it. It's kind of like an R4. Wait, one more. Hand those straight back so to Emil and company. Emil, hand one over to your partner. Nope, you each get a sheet. You can work with the partner, which definitely is a big advantage. Hand them back. Nope, there's 2 there. Good, okay. I don't think you'll use the sheet more than twice. I will give you this hint that I gave the other class, that the things I think you'll need the sheet for, I think you'll need the sheet for sure on number 8, and I would use this one. I think that'll make it go the fastest. On number 8, I'd use that substitution. There's 3 different things for cosine. It'll just save you a lot of time if I tell you use that one. But the first 3, you should be able to just draw little triangles, check with your partner, see if they got the same thing as you. And you'll hit number 5. That's what we just practiced. Then number 6, I would honestly skip it and come back to it at the end. Number 6, if you use the sheet right, it can be done, but it's a stretch. All right, I'm going to pause, give you a little bit more time. Okay, so I'm reading through the answers on that quiz. I just want to particularly address number 6. Number 6 is like a R4 level question. This is a really tough one. There won't be anything this beastly on the test. All right, or at least on the R3s anyway. Back to number 5. Most of the kids were able to figure out that one. Just a quick 1 through 4 is right here for those of you at home checking your work on this little quiz. And I'm going to post that quiz in case you want to look at these problems again. I'm going to post it online. All right, now we need to get to problem 7 and 8. So that's, let's see here. Here's number 7. We use a U substitution, and we end up getting 5 pi over 18 and 7 pi over 18. But a lot of people didn't notice that the directions said find all the solutions as opposed to find the solutions between 0 and 2 pi. It's actually easier when they say find all the solutions because then you just slap on a plus 2 pi k. That's how you find all the solutions. Now, if you use the 2 pi k and then you thought, well, I'm going to stick in k equals 0 and k equals 1, you were doing it right if we had asked for the answers between 0 and 2 pi. So if you stuck in k equals 0 and k equals 1 on all of them, that's great. You only have to know how to do that too. But if the question only asks for all the solutions, you leave this little tag on the end of them and you're done. It's actually easier if they ask you for all the solutions than if they say between 0 and 2 pi. If they had said between 0 and 2 pi, do you know you put in 0 and 1, and then you start being careful because what if you go over 2 pi? Just make sure your answer, if it ever comes out more than 2 pi, you go, oh, too big, cross that one off. Okay. Then, number 8. On number 8, we do a substitution off the sheet, and I even told you that one on the board here in class saying, number 8, it'd be smart to put in 2 cosine squared minus 1. Why does that work out nice? Because then it factors to this. How many were able to get it to factor? That's a key skill for this unit, is taking trig and factoring it. Okay, next we break it up into 2 little parts, and a lot of you figured out that this one, cosine, is down here, and the highest it ever goes is 1. So how is cosine ever going to be 3? It's not. There's no solution to that side. That does not mean there's no solution to the whole problem. That just means this side has no solution. You could still make this side equal 0. Do you get 0 times, no matter what this is, it's going to make it equal 0. So we still need to solve this side. It's not like, ooh, one part was no solution, I get to cross everything off. Nope. Just the right side has no solution. This left side comes down to this, and then your final answers for this. I love how to get to the end of a really hard honors pre-calc question, and then what you have is another honors pre-calc question. All that work, and you get to here, which is a separate question in itself. You got to draw the triangle and know where cosine is negative, so it can't be here and it can't be here, and you draw your, anyway, in the end, you would end up getting 2 triangles there, and it's 2 pi over 3 and 4 pi over 3 were the final answers to that question. How many of you had that question right with 2 pi over 3 and 4 pi over 3? All right. Okay. Now, if you struggled with this, obviously, that's a sign that you're not super well prepared. If you were fine on this, then you're in pretty good shape. Your assignment for tonight, I am going to post this little quiz. If you want to, you can go look at that again. But I would do the review worksheet, pick 4 problems that were of the type that caused you the most pain, and then have those ready to Dropbox tomorrow. Remember, number 6 was pretty much like our 4 level. Don't stress about that kind. That's all I got for you for today.